Hello and welcome. I'm going to be doing a couple of things today. First, I'm going to be doing a walkthrough of one of the cases from the finals of the South African Excel Championship 2024. And second, I'm going to be demoing one of the wackier lambdas that I wrote ahead of last year's Excel World Cup finals. Never ended up using it in the final. I've still not used it in competition. I'm not 100% sure if it would actually help in competition versus other methods, but I'll explain that when I come to show it to you in a couple of minutes. It is the lambda that writes lambdas, and it is, like I said, one of the craziest things I've ever written. But first, let's introduce the case. So there are 3 rounds at the live final of the South African Excel Championships. One case by each of the 3 case setters, which is Steen Walmerans, Jason Weber, and Rainier Wessels, who wrote this one. And I will do videos on the other ones at some point, but I tested them all while I was traveling and not able to record. So none of these are going to be live attempts, but anyway, it's what it is. So this is based on the game of Snap, and pretty simple. You play with a standard deck of cards, and if you have the same face value on 2 consecutive cards, then it's a snap, and one player has to yell and slap their hand down. And in the real world, it's all about who slaps their hand down faster. In this game, we don't really pay attention to that, but yeah, that's kind of all we need to know by way of background. So there's the biggest complexity in this was that there was some subtlety to the dealing order. So, usually in these games, because there has been a lot of these kinds of games in the Excel World Cup before, it's, this is the first card for player 1, this is the first card for player 2, this is the first card for, second card for player 1, second card for player 2, and so on. But is an interesting little twist on it. Rainier basically said, well, if your cards are dealt face down, then the first card that you play is the last card that you receive. So this is the first card dealt to player 1, first card dealt to player 2, second card, and so on. But actually, you're going to play them in reverse order. So this is the last card dealt to player 1, which is the first card that they play. So this first question just asks, what is the first card to be played in the round? And then you start to look for snaps and other things. So now the interesting kind of trade-off with these cases and the motivation for the crazy lambda I'm going to show you is there's always a balance between if you can solve the case like either in one cell, as I often do now that it's much easier to make bigger formulas with let, or in spread across one row, as I often would have done before, then you can take your entire workings and copy them down to later rounds and replicate it that way. But if you can't, or if you find it easier to work with more space, then you might say you're better off to build a data table and solve it that way. So in other words, build out a full model on a separate sheet, and then build a data table to run that for each of the different inputs. So like build it just for this input, make sure you get this output, and then run it varying the input to each of these things. And in theory, there's a middle ground between those where you build out your model column by column with as much space as you need, and then you gather all those things up in one big let statement. So you say let, first value be this first calculation, second value be the second calculation, build it up with as many steps as you need, and then you can either convert that into a lambda or just have it as a let here and just the first value, instead of being whatever it was here, just now points to this cell, and you can copy that formula down. And so the function that I wrote, which I named LAMBDIFY because it lambdifies your calculations, was something that basically does that process of grabbing a bunch of stuff and shoving it into a let, grabbing a bunch of stuff and shoving it into a lambda. So it'll be easier to understand if I just show it to you in action. So let's just say input. So the first thing we're going to do is split up the cards. So we'll say text split of this by semicolon space. And actually, I prefer to have things going down columns. So do that. And actually, sorry, I've already broken my own layout rules. So let's do this. Say input is this, and then call it card list is that. And in this case, we're just interested in player 1's last card, which is going to be the 51st of the 52 cards. So P1 first can be index of this, comma, 51. So pretty simple setup. Not hard to see how you would say let input be this, and let card list be text split of input by semicolon space, and let P1 first be index index card list, comma 51, and then return P1 first. And you get the same thing. It's just all of that stuff squeezed into one. But even if you've got all the calculations written out here, it takes a while to do that. So enter LAMBDIFY. So the idea is you point it at, so first you have to lay out your model like this, meaning each column is its own thing. It can handle single arrays that are multiple columns. I might get a chance to show you that one later, but for now, just ignore that. Let's assume everything is one column. So you have one array, which is all the names, and another array, which is all the formulas. And it returns a text string, which if I then copy value paste it, so it just takes everything literally. So I'll just point that to there to make it a little easier. And then here, you can see you've got input points to that, card list calculates that, P1 first calculates this. It also adds another variable, and my line breaks I guess are a little funny here, but it adds another variable called check, and then it returns P1 first. And so what does check do? Well, if I want to check my interim workings, it just stacks up all the steps along the way. So you can see here, it stacks all the names here, and it stacks all the variables here. So you get, here's the input, here's the card list, and here's P1 first. So I can kind of scroll down here and say, oh yeah, I see that the second last card here is the 3 of spades. And yeah, that's basically it. So it kind of automates this process of, like, again, you can, if you're as comfortable with lets as I am, you might find it, especially for something like this, you might find it no big deal to just write this all the way through right away. But as we get to some bigger things later in the model, you'll see that it gives you the kind of comfort and the visual audit of building everything out, along with the efficiency of then having it all in a let. So let's just grab all this. Let's just, I'm so funny, inadvertently. Anyway, so then we just need to replace this first value with this, and hopefully that should work for all of them, and it does. All right, so let's go to the next level. What is the card value that is snapped on first during these rounds? Assume every snap opportunity is utilized. So I'm going to use some of my other lambdas in here just so that I'm not, and I guess I should mention, now that this logic has all been captured here, I don't need to keep it here. So like this bit is no longer useful. This bit is still useful. Having the card list split is still helpful. So now what I'm going to do is just grab this, pop it in there. Okay, so now I want to know when snaps happen. So a few things here. First, I'm going to want to get the face value, because there's one level where it's done differently, but for the most part, the suit is irrelevant to the snapping. So the first thing is I've got, it's not even a lambda, just a named range. I've got just a list of suits. So to get the face value, I'm just going to say text before this column and suits. And that'll give me the face value always as text. So you'll see that those numbers are left aligned. I should mention, for LAMBDIFY to work, it's very important that the setup be like this. So in other words, I can't, have this pointing to here and then a second cell pointing to here and so on down. It has to be all array-based construction. Okay, so like for example, when I was doing the P1 first, I could not just link down to the 51st cell there. I had to use an index. That's probably a better place to demonstrate it, but never mind, I didn't do it there. Okay, so now I've got another handy one here, which is prev, previous value from an array. So the x and you can make it something other than an X, but whatever, fill with PQRT. Just wherever there's a blank, it fills in that. But so it's saying, you know, here the value is 4. The previous value, which is just pointing to the row above it, is that 4. And then here the value is king, and the previous value is 4, which is that 4. So it's basically just always pointing up and to the left. You can change the offset. So for example, here's an offset by 3. So now this is the value from 3 steps above. So, you know, 3 before the 6 is a 4, 3 before the 3 is a king. But by default, if you leave both of those out, it just uses an X and it matches one value. So when I want to know, am I snapping? All right, let's just call it rep val. I can just say previous equals current, and that matches there, and it matches there, and it'll match various other places later on. And then the question here was just, what's the card value that is snapped on first? First snap. And here we can just XLOOKUP true in this array, returning from this array. And that is telling me that it's 4, which, wait, oh, sorry. Yeah, that's because I haven't put them in order, which would definitely help. So let's put them in order now. So the order that the cards get played in, I have not taken account of. So let's put them in order. So first of all, let's do, yeah, let's spread it out. So let's do play ord. So first I'm just going to do wrap rows of this by 2. And that's going to give me, so here's the first card, delta player 1 goes into player 1's column, first card, delta player 2 goes into player 2's column, 1 here, 2 there. So it just does exactly what it says in the tin, wraps everything in rows of size 2. But now, remember, they're done in reverse order. So these are the first ones to be played, then these ones, then these ones. So we need to reverse the order of these and then flatten it back out again. So I could, again, just do this in one formula, but to show you the benefits of LAMBDIFY, I'm going to just spread it out. So I guess I should call this deal order to make it a little logical, and then we'll do play order. And so for that, we can just do sort by this, and we can sort it by sequence of 26 descending. And so that gives us the first ones to be played are 6 and Jack of clubs, and sure enough, those are the last ones to be dealt. And the next last ones to be dealt are the 2 of hearts and the 5 of hearts, and sure enough, those are the next ones to be played. Okay, so then I can just do play ord flat to get them back in order. So then the first card to be played is the 6 of clubs, then the Jack of clubs, then the 2 of hearts, then the 5 of hearts, and 2 call just flattens them out in exactly that order. So now I just need face val to point to there, which is, all right, nudge this out of the way, which is column H. And now that's better. And sure enough, down here, I've got a repeat 9, and 9 was the answer we were expecting. So again, like I said, there is part of me, obviously I'm kind of chit-chatting a lot, trying to kind of give you a sense of how this works and introducing lambdas and blah, blah, blah. But it's also honestly not clear to me that this is actually an advantage to use in the competition. But that's why I'm trying it out a little bit more, because I haven't really done that before. So I'm 90% sure that it will work with this setup where you've got one header for 2 columns. But let's check, I guess. So the first thing is, if I just do it, yes, it gives me that. And then the second test is if I change this to check. Yes, so it is correctly outputting deal order as 2 columns and play order as 2 columns, and each one of those only goes down half as far. So the NAs are just where there's no value there. Okay, so now I've got something that works for that. So let me first switch it back to first snap, because that's what I want to output. And then let's grab all of that, bring it over here, put it in here, and just change the input to be this. Okay, next. Level 3, during which round is the second snap? Okay, so this is basically fine, except that you'll note that I labeled this as repeat value rather than snap, because there is just one subtlety, which is where you have, let me just link this to here, and actually if I link it, maybe that will also address some of the funkiness where it was, where it was giving me the whole big literal text string. Maybe, let's see. If I do that, yes. Now it just gives me input pointing to the cell that this is pointing to. So that's good. That's probably what I wanted to do. But so, sorry, the twist with this one is, let me just see if I can find an example of it here. But basically, if you've got 3 of a value in a row, no, there's not an example of it there. But I think it does talk about it here. So here you've got 8, 8, and a snap. When you snap, you pick up all the cards that are snapped. And so if there was a third 8 here, that would be a repeat, but it would not be a snap because there is no existing 8 to put it down on top of. So that is now the first 8 of a new hand. And so we need a separate thing for whether this is a snap or not. And the logic of that, if I just sort of start off in a non-array way, the logic of that is basically cumulative. So you're going to say, if the previous value was a snap, then there's no snap. Otherwise, it's this. So let me just copy this over here and just show you some simple examples. So if I say false, false, true, 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 then you can see. So this 3 repeats here would be equivalent to 4 same values in a row. So the first 2 would form a repeat and a snap. The middle 2 would form a repeat but not a snap because the first one of them has already been picked up. The last 2 would form a repeat and a snap. And then whenever you have this this logic built up like a reference to the previous row and a reference to the current row, you can turn it into a scan to do it for the whole column. And you do need to be diligent about doing things in array formula ways if you're going to use LAMBDIFY. So we're going to scan starting from false, going through this thing of repeat values, and we're going to say lambda AV, if A, then false, otherwise V. Pretty sure that's right. And so then the question was, during which round? Oh yeah. So the rounds are just first 2 cards, for 1 card for each player is round 1, next 2 cards are round 2, and so on. So I'm just going to add a column round. I'll just call it R&D because I prefer not to name my steps things that are functions when I remember, which is not always. And for that we can just do, we'll do sequence of 52 starting from 1 in steps of, actually no, I was about to do in steps of 0.5, and then I remembered sequence sometimes acts weird when you give it non-integer steps, so I'm just going to do starting from 2 in steps of 1, divide by 2, and then we can round down to 0 decimal places. That gives me 1, 1, 2, 2, 3, 3, and so on all the way down to 26, 26. So that's the round number, and then I'm just interested in the second of these. So we'll call it snap rounds, snap RNDS. We filter by rounds on snap, and then snap round 2 will be index of this 2. And then we can, not lambda, but LAMBDIFY this, sorry, gaps in the middle, gotta be careful. And this. And then we can grab all this, bring it back over here. Oops, I hit Control C, meant to hit Control V. And then we just need this to point to the new value, and hopefully it'll all work. And it does. Okay, level 4. In this round, suits are also in play. Therefore, a match on the suit will also result in a snap being in play. How many snaps are in play during the first 26 rounds? Okay, so I guess here I'm going to need rep suit. And that's just going to be right of, is the player order flat? That's the one I'm interested in. Right of that equals right of prev of that. So let's say, so that spade, club, spade, heart, heart. And we got a match there. Club, spade, club, heart, club, club. And we got a match there. Okay, seems to be working. So then call this rep either. We'll just do map this, this, or. So here we've got a match on value. Here we've got a match on suit. All good. And then I just need this to point to column L instead of column J. And it's when you're getting into more complex things like this that I can see that having it all laid out will make it easier to edit things than having it all in one single formula, which is why I think maybe there is a case to be made for LAMBDIFY helping me, but I'm not totally sure. Anyway, sorry, what is the question I need to answer here? How many snaps? So I guess I'll just make this minus minus to convert those into ones and zeros, and then call it num snaps. That can just be sum of these, and I don't need those two anymore. And 14 is not the, oh yeah, that's because that is pointing at 149. So let's just check. And it gives 11. So that's good, I think. So we'll bring it over here, value paste, and then just need to point this to here and copy it down, and that works. Hooray. So we're gathering momentum. I don't think we're going to finish in the 30 minutes, but never mind. Okay, back to card values only. All right, so again, all that logic is now baked into the let, so I can just kill this and this, and point this. Whoa, why is my mouse not responding? Hello. There we go. Point this back to J4 hash. Okay, and now what else do I need to do? Assume the player who places a card that results in a snap calls snap first, wins the snap, just looking at the starting hands, decks, therefore only looking at the first 26 rounds. How many cards did the player who collected the most cards in the game collect? Okay. So there's a lot going on here. Main thing is we need to figure out runs. So up to this snap, how many cards were collected, and then we'll have to figure out who collected them. Okay, so I guess first I'm going to say player, and that's just going to be, I guess I will say if, let's do mod sequence 52, trying how to do this, sequence 52 minus 1 by 2 plus 1 will give me 1, 2, 1, 2, 1, 2, 1, 2. Okay. Then, so I need the number to the snap. And that is going to be a scan, but how exactly is the scan going to work? So I think first we're going to want, I think it's prev. Wish my head was a little clearer on this, but so basically the idea would be that we'll reset to 1 whenever there's a 1. So here we would count all of those, then reset to start the next count here, and count until we get to 1, and then reset there. So let's try doing scan 0 prev of that, and the lambda is going to be lambda AV. So we're going to say if V equals 1, then 0, otherwise A plus 1. So then we go 1, 2, 3, 4, 5, 6, 7, and that's how many cards are picked up at the first snap. Then we go 1, 2, 3, 4, 5, 6, 7, up to 11, and that's how many cards are picked up the second snap. So that works. Okay. So this is, I guess, run count, run CNT. So then I'm interested in I'm going to actually switch this, put it here so that I can take these two together. I want that. Oh. Okay, so let's filter our run count by snaps. So the first snap picks up 7 cards, the next picks up 11, then 9, then 8, then 15. And then I'm going to do the same thing here to see who picked them up. So filter player by snap. Oops, get rid of that extra P that snuck in there. So in other words, player 1 picks up 7 cards at the first snap, player 2 picks up 11 cards at the second snap, and so on. So we'll call this, I don't know, snap CNTS, snap counts, and snap player. And then to figure out who picked up how many, we can say equals group by. So we're going to group these row fields by these values and sum. And then we're going to want 0, 0, minus 2. This is like a standard setting for drop totals, drop everything else, and sort in descending order by the value column, which I use a lot for questions of what is the most of blah, 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 blah. And then from there, we're going to take, actually, no, sorry, I'm embracing LAMBDIFY. I don't have to squeeze everything, so I'll just call this group, and then I'll call this most picked. And that can be index of this, and you have to refer to the dynamic array by row 1, column 2. And then I've already got my LAMBDIFY, so I can Control C, whoops, where we go? Bring it over here, Alt ESV. So you can see, you know, once you've got the momentum going, this setup, especially if the levels build on each other in this way, can be pretty helpful. But I honestly don't know, like this has taken me half an hour. It would not have taken me half an hour to do it other ways. But I've also been chit-chatting a lot and trying to explain it, so I'm not sure. Maybe. I don't think it's going to be the blow-away game changer, but on the right case, it could be kind of helpful. Anyway, okay, same rules applies on level 5. During which round does the losing player run out of cards? Yeah. So this is this was a sort of feature of this one and also one of the other South African finals cases, is that the last level actually requires almost a totally different model than all the rest, because here, so everything up to here, we've just been playing out the 52 cards. But for this one, it's basically when you get a snap, you pick up your cards, you add them to the back of your deck. And so you'll play through way more than 52 cards before the game ends. So I'm not going to attempt to turn this model into that one. I might just skip that one for now. I'll maybe put a funky let solution in the comments if I remember. But okay, let's do this. Which suit is played first most during level 1? So one way to do that would be to say let call it L1 suits be right of this. Then we're going to that same group by trick. So we're going to group by L1 suits by L1 suits. We're interested in rows, which serves to count them. 0, 0, minus 2. That'll give us the whole thing, and then we just want at. We'll take the top left value of that, which will be the suit that occurs most often. In level 4, what game number saw the least amount of snap conditions, excluding example 4? So this is just an XLOOKUP 0 in level 4, wherever that is here, returning from the game number, exact match or next larger item. Good. What's the lowest number of cards collected by the winner? So this is also kind of just an XLOOKUP. I think it's at the lowest number, so XLOOKUP 0. No, sorry, what's the lowest number? So it's just a min. It's not even an XLOOKUP, because we're not looking for a game number. We're just looking for the cards. So level 5. All right. So, you know, there's my 30 minutes. I actually got a respectable amount done, but okay, so across all 110 games, excluding examples, which game number had no snaps on card value in the first 52 turns, i.e. after every card is played once in the order described above? Ignore level 4 rules, only consider snaps on value. Okay. So I think this is a case where my weirdo setup here can come in handy. So I just wanted my number of snaps. So let's just kill all this and go num snaps. And that can be some of this. And then I want sequence of, I think it's at 110. So we'll just pull in the data for all the cases. So we'll look up the game number in column B, returning from the game details in column G. That gives me everything, and then let me then show you an extra twist of LAMBDIFY, which is, so I've only shown you how to use it to make let so far, but if you want to make it into a lambda, then you just tell it how many of these initial columns are going to become lambda arguments. So in this case, there's just one input, which is the first column. So if you want to make it a lambda, you get this. So you get a lambda of one variable and an optional check, which is just the option to output that check that has all the steps that I showed you before. And then it goes into a let and just goes through all the same steps. So I'm going to take this lambda, everything down as far as, but not including the argument, and I should be able to say map of this by that lambda. Get rid of the equals, go to the end, and there it is. And what the heck was the question? Sorry. Which game number has no snaps on card value? Okay, so we could just do an XLOOKUP, but we want to validate that there is in fact exactly one game number with 0. There is, hooray! So that works. So we can XLOOKUP 0 in here. Actually, just XMatch 0 against here would work because they're in game number order. Okay, and then across the first 52 turns, in all 110 games, which card value produced the most snaps? So, to do this one, I think we can do it with a similar map logic to here, but it'll need to be a little bit different, which is, so instead of the number of snaps, I want the number of snaps by face value. So, I guess let's do unique. I just want to get all of my distinct face values. I guess I can have them in any order, it doesn't really matter. So snaps by FV face value. Let's just insert a bunch of columns here. Have I done enough? I'm not sure. Let's bring this over and I'll be able to see if I've done enough, I guess. I have. So we'll do this. Then we will do, I can't do a counting. Dang. All right, so what we can do is, so first we can do this equals this. And then I'm only interested in matches where it's also a snap. So we'll multiply that by snap. And so that'll give me, let's see, here there is a snap and it's on a 10. So it drops that in the 10 column. That's exactly what I want. Then I just want to sum those up. So we'll do bicol of all that, sum. And that gives me my snaps by face value. And then if I'm going to map it, then I can't have a multi-part output. I have to have a single part output. So let's do conc for concat. I won't actually concat, I will array to text. And then, this is unhappy. Oh, yeah, because these have somehow ended up slightly different sizes. So then I get my crazy lambda. I come here, I map all of these by that lambda. That gives me that. And then I want to be dynamic about it, but actually in this case I only need to do it once, so it's perfectly fine to just copy it down. And then I need to repeat these values to interpret this. So there's my values, and then I just need to sum, oops, sorry, these should all be minus minus, so that I can in fact sum them. So then I just need to sum each of these columns to see how often each of them happens. And if all of this has worked, what is the question? Which card value, right? Yes, card value. So A, there should be a unique maximum. So the max is 33. I see 32. There's 33 for 7, and that is the only one. So hopefully I should be able to say XLOOKUP. If I XLOOKUP 200, there's only 110. No, that's not enough actually. Let's see. Well, the most snaps there could be in a game, I don't know, 26, I guess, times 100. So if I XLOOKUP 5,000, that's something that is bigger than any of them could even theoretically be in there, returning from here. And I want exact match or next smaller item. And it's wrong. Dang. All right, so something went wrong there. Slightly disappointing finish, but considering this video is already well over half an hour, I am not going to attempt to diagnose what went wrong. I think the idea works in theory, but I've stuffed something up in practice. I think that building it this way does reduce the odds of me breaking, of me like making a silly mistake along the way. And the other thing is, like I said, because all of the earlier steps, because all the logic for them is now completely captured in here, I can feel quite safe breaking the model in the way that I did like in level 4, where if I had a data table that was still kind of linked to this, I'd be worried about breaking the model. Then you end up with like, you make different copies for every level, but then you're running lots of data tables. It's very calc intense. I don't know. I don't think that this is going to be my golden weapon that just slays all cases, but I am going to practice using it a bit because I think it's pretty cool. I am also going to share my my Lambda workbook. I know I've been talking about this for a while. I'm kind of unabashed about the fact that, during the summer I spend time with my kids and much less time with YouTube. So I'm not exactly sorry for that, but I am determined that I will share my original Lambda workbook before the qualification rounds, so that anybody who wants to use it to help to pave their way to Vegas can do so. And I will probably, I'm not 100% committed to including LAMBDIFY in that, because I do think it's really cool, and maybe I'll keep that as my secret weapon, except that I just showed it to you all, of course, so not totally secret. But I'll probably include that one as well. Anyway, that's all coming soon, because there's only like a month to go until the qualifying round, so I will absolutely, definitely share it before then, but I do want to share, enough preliminaries that people can understand it and understand the logic and whatever before I just be like, here it is, and everybody has to use it without understanding it. So anyway, that's all I got today. Thanks to Rainier for a fun case and for letting me test out the whole set of the South African cases. There was really cool stuff there, and like I said, I'll have videos of the other 2 finals cases before terribly long. That's all I got for today. Thanks for watching. See you next time. Okay, so I have to add redemption for my crazy lambda approach, because the second I turned the camera off, I looked at this, looked to see what the answer was, and it turned out the answer was 7. It was just 7 stored as a number instead of 7 stored as text. So yeah, got the answer right. So pretty happy with that. I didn't do level 6, and I may still share a crazy lambda approach to doing that in the comments, but since I had ended on such a bad note of my cool new toy by getting the question wrong, I thought I should let you know I didn't get the question wrong. All right, that's all I got for today. Thanks for watching. See you next time.